It's easier.
All right, let's go ahead and take a look at the handout that you've been working on for the past few days. Go ahead and get that handout out. We've been working on a 3-page review sheet that should serve you well as we look ahead toward the test coming up on Friday.
Probably the best one we can do.
All right, let's go ahead and take a look at these together. On the first problem, the perimeters of two similar polygons are in ratio 5 to 4. The side of the second polygon is 20 millimeters. Find the corresponding side of the first polygon. And Kendall, first of all, what did you get for your answer? 25 millimeters. How many had the same answer, 25 millimeters? Let's take a look at this together. Anytime you're given anything about similar polygons, you know corresponding sides are proportional. But you also know not only are sides proportional per the ratio of similitude, but the perimeters have the exact same ratio. So we know that perimeter is to perimeter as side is to side. Well, they gave you the ratio of the perimeters. That ratio is 5 to 4. And if that's the ratio of perimeters, that's also the ratio of similitude. Therefore, it is the ratio of the two sides. It said that the a side of the second polygon was 20 millimeters. So we should put that in for the S prime, cross multiply to solve for the S. That's where we would have gotten 25 millimeters. If you had 16 millimeters for your answer, anyone had 16 millimeters, you just put the 25 in the top instead of the bottom. So just be careful paying attention to the first versus second kind of thing there. Questions on the first problem? Going into the second problem now. Two corresponding sides of similar polygons are 8 centimeters and 11 centimeters. The perimeter of the first polygon is 44 centimeters. Find the perimeter of the second polygon. Genesis, what did you get for your answer?
60.5
centimeters, or 60.5 centimeters. Good, either 60.5 centimeters or 60.5 centimeters. How many have that answer for problem number 2? Everyone's good to go there. Good. Same proportion, P is to P prime as S is to S prime. You're given the 8 centimeters and 11 centimeters, and those centimeters cancel. You're going to take the 44 centimeters, plug it in there. That centimeter doesn't cancel, which is where your unit comes from when you solve for P prime. Looking at the third problem, the sides of a pentagon are 3, 5, 8, 6, and 10 feet. Another similar pentagon has a perimeter of 48 feet. Find its corresponding sides. Let's see here. Audrey, what side did you get that corresponded to the 3-foot side?
12. I got A.
A is 12. Quentin?
4.5.
I got 4.5 feet for side A. What about side B, Quentin? 7.5 feet. Did you get side B correct? Okay, so we're off on all of them then. Go ahead and continue, Quentin. Side C?
12 feet.
That's 12 feet. D?
9 feet.
9 feet. And E?
15 feet.
15 feet. Let's take a look at this really quickly. The first thing we had to do is find the perimeter of the first polygon. I know the perimeter of the similar polygon or pentagon is 48 feet. And I'm sort of given, Audrey, the perimeter of the first one. But what do I have to do to get the perimeter of the first one? Jamie?
Add the all the sides of the pentagon.
Right, add the 3, 5, 8, 6, and 10 together, and it should have given you 32 feet for the perimeter of the first polygon. So that's going to allow the feet to cancel. And by the way, if you want easy math, reduce this down. What would this ratio reduce to, anyone?
It's 8 and 9. 8 and 6, 2/3.
2 to 3. You can divide a 16 out of both of them and get a ratio of 2 to 3. So that's the ratio of P to P prime. Questions on that, Audrey and others who may have missed it? All right, how many like Quentin? You got all 5 answers correct. Okay, a couple of you did. Okay, so Chris, Genesis, Audrey, questions on how to get the perimeter first of all.
That's what I didn't do.
All right, yeah, that's important. And that way you have P is to P prime as, well, you know the 32-foot perimeter has sides of 3 feet, 5 feet, 8 feet, 6 feet, 10 feet, right? And then you solve for A. And then you solve for B. And then you solve for C and so on and so forth. And that's how we got those answers. Again, the answer is 4.5 feet, 7.5 feet, 12 feet, 9 feet, 15 feet. And again, if you make sure you jot those down, you can go back and rework the problem as needed for review, looking ahead toward the test on Friday. Questions at all on this proportion, perimeters and perimeters, sides to side for similar polygons? All right, let's change gears here. And as we go to the next problem, problem number 4, says the hypotenuse of a right triangle is 16 inches, one leg is 12 inches, find the length of the other leg. What would I have to do here? Back to Audrey for redemption. Well, you know two sides of a right triangle. You're just missing the third side. Use the Pythagorean Theorem. Audrey, what did you get for your answer?
4 times the square root of 7 inches.
Good. Initially, the square root of 112 inches, but good job reducing that to 4 times the square root of 7 inches. How many had that for that first Pythagorean Theorem problem? All right, for those who did not, check your picture. Again, technically you don't have to have a picture. Technically, if you recognize, oh, right triangle, two sides, finding third, you just have to make sure the 16 goes in for the C, because that's the hypotenuse, the 12 in for A or B, and then of course solve for whichever letter you didn't already plug in. Careful on your squaring. They should be memorized from past years in algebra. Subtract the 144 to get the 112 equals B squared. And then again, taking that square root, just a matter of reducing it down. Hopefully at least saw there's a 4 in there. And see, 4 goes in 2 times. With 3 left over, it goes in 8 times. Well, there's another 4 in there, 4 times 7. Take out a 2, take out another 2. There's the 4 times the square root of the 7. Of course, we'll use the inches for our answer. Any questions on that? All right, looking at the next one. Legs of a right triangle, 14 centimeters, 8 centimeters by the length of the hypotenuse. And Chris, once again, Pythagorean Theorem. Hopefully you recognized that. What did you get for your answer?
2 times the square root of 65.
Good. 2 times the square root of 65 centimeters is correct. How many had that answer for this 5th problem? All right, Quentin, back to back now, had some struggles. Questions, comments on these two? Did you use Pythagorean Theorem?
No idea.
How in the world did you try to do it?
You were right triangle and then labeled everything.
So you drew right triangle, and you labeled legs as 14 centimeters and 8 centimeters. And then what did you do? Okay, gotcha. I should have actually thought about that. Not an uncommon error to imagine, 30, 60, 90, x times the square root of 3, 2x, 16 centimeters. Is that what you had?
Yeah.
Only problem, is 14 the same thing as 8 times the square root of 3? No. Check it on your calculator if you're curious. Also, is there any indicator that we have a 30-degree angle or a 60-degree angle? No. So don't imagine a 30, 60, 90 where there isn't one. Easy mistake to make. Lots of students in past years have done it, which is why I probably should have thought of it. Same thing coming over here where we have the 16 inches, 12 inches. Well, did you perhaps guess 8 inches? Okay, and again, do we know that there's a 30-degree or a 60-degree angle? Number one. Number two, is 12 the same thing as 8 times the square root of 3? No. So, yeah, don't assume 30, 60, 90 where it is not present. Questions, comments, any other? On 5 or 6, anyone, or 4 or 5, anyone do something different? Quentin, we already addressed, he imagined special triangles that weren't there.
On the 4th one, I did the same thing. So
What?
On the 4th one, I did the same thing.
Number 4, you also assumed a 30, 60, 90 where it did not exist.
I caught myself on the 5th one.
Okay, and caught yourself on the 5th one. All right, any other questions, comments on that? All right, let's go to the next one. Number 6 is the next to last one on that first page. And Jamie says each side of an equilateral triangle is 6 inches. Find the length of the altitude. There's actually a couple different ways you could approach this problem. What did you do, Jamie?
I did segment is altitude as altitude is a segment.
There is a proportion segment is to altitude as altitude is to segment, but class, that's in what kind of triangle?
Right triangle.
A right triangle. What do we have here, Jamie?
An equilateral.
Can an equilateral triangle ever be a right triangle?
Yes. No.
Because a right triangle has to have a hypotenuse, which is always the longest side. An equilateral triangle is all equal sides. Furthermore, every angle of an equilateral triangle has to be exactly
60.
60 degrees.
Mm-hmm.
You can't have a 90 if they all have to be 60, right? So no, it wouldn't work there. But that's interesting because did you hear what I said a moment ago to Quentin? I said, is there any indicator in the triangles that I just erased? Is there any indicator of a 30-degree angle or a 60-degree angle? No. Is there any indicator of a 30 or a 60 here, class?
Yes.
Yes. Every angle of an equilateral triangle is 60 degrees. So here, you could use 30, 60, 90. You draw your equilateral triangle. In fact, this is how I introduced the 30, 60, 90 to you, was we started with an equilateral triangle. We drew the altitude, and then I said, well, look, I've got a 60-degree angle here. I had a 60 here with 30 degrees on either side, and we've got a 60-degree angle here. Obviously, altitude implies right angle. There's my, or perpendicular, there's my right angles, there's my 90. I got a couple 30, 60, 90s, and it says each side is 6 inches. This is 6 inches, this is 6 inches, and all of this is 6 inches. So, Jamie, I assume you actually probably did this next part correctly. I assume you identified that if the base is 6 inches, each segment is
3 inches.
3 inches. Where we fell off the wagon a little bit here was saying 3 is to x is x is to 3, in which case you would have gotten 3, which is not correct. A couple ways we could go here. Probably the easiest way to finish this out, Jamie, is to say, well, if this is 3, and if this is 6, then this is
3 times the square root of 3.
3 times the square root of 3 inches, because this is our x times the square root of 3. That by far is the easiest way to get the correct answer. But you could go Pythagorean theorem, couldn't you? You could say c squared equals a squared plus b squared, where which of these is the c, class?
The 6 inches.
The 6, that's across from the right angle. So 6 squared equals, there's the leg that we know, plus, and there's the leg we don't know that we're solving for. You'll get the same answer doing it that way. So Pythagorean theorem would work, because you have a right triangle, or 30, 60, 90 is so much quicker. How many did have 3 times the square root of 3 inches? Oh, only Quentin. Questions on that?
Yes.
When there is an indicator of a 60, you need to spot the 30, 60, 90. Does that make sense? And again, did it say there was a 60 degree in there? Yes, when it said equilateral triangle. It was in code, reading between the lines a little bit, so to speak. We've got another hidden triangle in the bottom problem on this page. Go ahead and read that one for us, if you would, Kendall.
Each side of the square is 12 inches. Find the length of either diagonal.
A picture really helps, by the way. Here, without the picture, you probably don't think 30, 60, 90. Here, unless you draw the square, which has all sides equal, and you draw the diagonal, you probably don't see the 45, 45, 90, do you? Draw pictures, right? So lesson learned from that. If we know that each side is 12 inches, then to find the length of the diagonal, again, if we're thinking 45, 45, 90, class, our diagonal should be 12 times the square root of 2 inches. Even if you didn't see 45, 45, 90, if for some reason the fact that the legs were equal, it just didn't register, but you at least saw, hey, there's a right triangle, Pythagorean theorem, this is the hypotenuse, c squared equals leg squared plus leg squared. Get your 144 plus 144, 288, that's 144 times 2. Hey, that's 12 times the square root of 2, and then you're like, oh, it's a 45, 45. Now, maybe you realize it after the fact, but a couple ways we could do that. How many did have 12 times the square root of 2 inches? Okay, a couple of you that time saw it. Did you draw pictures? Ah, those who didn't get it. How many of you, anyone draw the picture, still not get it? You drew the pictures and still just totally missed it? Questions? All right, isosceles right triangles in there. Turn the page.
You were calling us that.
What?
I thought you were calling us isosceles triangles.
Oh, I wouldn't call you that. They're right. You weren't.
He doesn't call me an obtuse anymore.
I could. No, just kidding. I'm picking on you. All right, let's take a look at the next page here. 2 adjacent sides of a rectangle, 6 inches, 12 inches. Find the length of either diagonal. A student before school today was mentioned to me, he said, is there a formula to find the length of a diagonal? And I said, draw a picture. And so the student drew a picture and labeled adjacent sides as 12 inches and 6 inches. May have also labeled, hey, I know opposite sides of a rectangle are equal. That means this is 6 inches. Hey, that means this is 12 inches. But how to find the length of the diagonal? Well, I said, what picture do you see? And the student answered, rectangle. What else do you see?
Rectangle.
Oh, two right triangles. Question, is there any indicator of a 30 or a 60?
Yes.
No. Where'd you get a 30 or a 60 from?
I was just guessing.
Don't guess. No, this is geometry. We don't guess in geometry. We know in geometry. Is there any indicator of a 30 or 60? No. Is there any indicator of a 30 or 60 here? Yes, because we memorized. We know that every angle in an equilateral triangle is 60, right? Is there any indicator of a 45 here? Yes, because we know that if the legs are equal, the angles are equal. We know they're complementary. We know they're 45. Do we know anything about a 30 or 60 here?
Yeah.
No.
Well, if the 6, across from the 6, that would be a 30, and across from the 12 would be...
How do you know? You're guessing. This is geometry. We don't guess. You're making out like CNN, being like, well, we speculate racism was the cause of everything that happened today in the news, so white people are terrible. How do you know that? Maybe some are, but how do you know that? There's no proof for that. Don't speculate stuff. But I do know, because it's a rectangle, there are right angles in the corner, and I do know that I have two sides of the right triangle, and I'm only missing the third side, class. So while I know nothing about a 30 or a 60 or a 45, I do know I could at least use the Pythagorean Theorem. So what's the moral of the story I'm trying to pound home here? If there's an indicator, a clear indicator of 30 or 60 or 45, go special triangles. If there's not, you still have Pythagorean Theorem to fall back on. In fact, in both cases, even if you didn't spot the special triangles, you can at least fall back on Pythagorean Theorem. So spot right triangles, use Pythagorean Theorem. How many did that on this problem? Only Jamie. The rest of you work it quickly. Find for me the length of the diagonal. Let me check her answer. And you are correct. Good, Jamie. Let's let the rest of the class catch up to you. Now, I give you a hard time, but please know, I do the same thing to every class, every year. Every year the students make the same mistake. This is part of the learning process. So I'm certainly not upset at you, but I am trying to drive a point home to get you to think critically. Do I know this or do I think this? And you have to be able to discern between the two. We actually live in a society today, as I just illustrated, that doesn't discern between the two. That which they think, they assume they know. Oh, be careful. I would even say to conservatives, do you know there was widespread election fraud that caused the results of the election to change? There are a lot of conservatives. Oh, of course I know it. No, you don't. You think it. There isn't concrete proof, and that's why it couldn't make it to court. That's why it could not win. You think it. Nothing wrong with thinking it, but you have to discern between do I think it or do I know it. Frankly, I think it too, but I don't know it, so... And that's where geometry is so good for training the brain. All right, we have our answer here. And Jamie, what did you get?
I got 6 times the square root of 5 inches.
How many, now that we reworked, you got 6 times the square root of 5 inches for the answer? Okay, still did not get that.
I got 6 times square root of 30.
Ah. Is this A, B, or C? It's across from the right angle. It's got to be C. So when plugging in the numbers to the Pythagorean Theorem, the hypotenuse, remember, that's the one across from the right angle. That's got to go there. The other two will go in the AB spot. So you got to, when you use Pythagorean Theorem, make sure you're careful to plug it into the correct spot. Make sense? Any other questions, comments on the first one on the second page? Starting to see how to think through these problems. Again, this was kind of a, let me give them a whole bunch of problems. They'll get some, they may miss others, but I can teach them how to think through these kinds of problems because there's such a wide variety of questions. I like the next one. Go ahead and read this one for us, if you would, Genesis.
The shorter diagonal in the rhombus is 16 centimeters, and the longer diagonal is 30 centimeters. Find the length of each side of the rhombus.
All right, so now I'm going to take you through the whole mental process here. You see a problem, and your first thought is, I don't know. And that's correct. You don't know. So what do you do when you look at it like, I don't know? You draw a picture. How many did draw a picture? You should have done so. Do so now if you did not already. When you draw your rhombus, again, try to draw it true to form. But again, we don't trust our eyes. And we've got, within the rhombus, we've got a couple of diagonals. Now, as you're drawing your two diagonals, you need to think, what do I know about this? Kind of like we did with our unmemorized constructions, remember? With our sketch, kind of the same mental process. What do I know about these diagonals I just drew? What do I know about the sides of a rhombus? Well, let's start with the easy one. What do I know about the sides of a rhombus, class? They're all equal. What do I know about the diagonals I just drew?
They bisect.
They bisect each other. Now that's important, because if they bisect each other, and you know the longer diagonal is 30, and you know the shorter diagonal is 16, then that means each piece of the shorter is 8, and each piece of the longer is 15. What else do I know about the diagonals?
They form right angles.
They're perpendicular to each other. Now, if you didn't remember that fact, you literally can't solve the problem. But if you do remember that they should be perpendicular, contrary to what my picture shows, right? Because it's not a perfect rhombus, then you're now thinking, wait, I do have a rhombus, but I also now, class, have 4 little right triangles. And out of every right triangle, I know how many sides? 2. And I'm only missing? Do I know anything about a 30-degree angle? 60? 45? But I know 2 sides, and I only need 1 side. So I should just use the Pythagorean Theorem. How many did that on this problem? Do it now. We're not working on proofs, but the mental skills we developed on proofs, we've got to keep using. It's almost like asking yourself, what clang do I know about this? You're just not doing a proof with it, you're doing math with it. And when Genesis has it, Genesis, give us your answer. Do you have your calculator today? Is it in your locker? Go get it. You're going to need it today. All right, Chris, what did you get for your answer?
17.
17 centimeters. How many have the same thing? 17 centimeters now that we reworked it. Questions on this? Let's take a look at the next picture. Now, this time I gave you the picture, which means you can kind of just go off clang memory. Now, it's been a little while since we've seen this picture. A triangle with a line drawn, DE, parallel to another side, AB. What should we be thinking when we see this picture? There's actually a few different thoughts that should go through our mind. Ethan, what's one thought that should go through our mind? Oh. Jamie?
Is it bottom is to top as bottom is to top?
Yeah, bottom is to top as bottom is to top should go through our mind. Ethan's mind has now been fixed. Ethan, what's another thought that should go through our mind? Hole is to bottom is hole is to bottom. What's another thought that should go through our mind, Quentin? Very good. All of those thoughts should be going through our mind right now. We should label our sides, 10 for AC, 4 for the bottom here, 9 for EC, and we're looking for the BC, the whole thing here. We should also observe, if I know the whole is 10, the bottom's 4, class, we know the top has to be 6. Which proportion, I've got 3 of them, which should we use, Audrey? Yeah, on this side I've got a hole and a top, so let's do hole is to top as hole is to top. X is to 9 is 10 is to 6. When we solve, we got what answer, anyone?
About 15.
15 inches. How many had the 15 inches? How many forgot the proportions? Questions on solving it then. Audrey, you say, remember the proportions, what happened?
I think I did 9 minus x instead of whole to top.
X minus 9? Better yet, instead of 9. Now you could do that as long as you wrote it correctly, x minus 9, not 9 minus x. You could say bottom is to top as bottom is to top. You could, I suppose, do that. Is that what you tried to do? You just have the 9 minus x instead of the x minus 9, and of course that'll mess things up for you.
Top as bottom is top.
Me too.
All right, so you also use the x minus 9?
No.
Oh, okay, I see. You just used x, you found it to be 6, and then you added the 6 and 9 together to get the 15. That works as well, as long as you remember the extra step to go back and add and don't leave the 6, which is the temptation on a quiz or test. All right, that works as well. Any other questions, comments on that picture? All right, looking at the next picture, one that we've seen a little bit more recently, and what should be going through our mind when we see this picture? Ethan, for some redemption.
Secant into tangent. is tangent is to external segment.
Perfect. Secant is to tangent is to external segment. We know the secant 15. We have the chord 9, but we don't know the external segment. Well, that's easy enough, right? 6. And so we're solving for the tangent here. And what do we get? Comes out to a radical we have to reduce, class.
3 times square root of 10.
Oh, you already got it. 3 times the square root of 10 centimeters. How many had 3 times the square root of 10 centimeters? Excellent. We should have for this picture. Unable to locate? No clue where it ran off to. I'm loan you one for now since it'll come in handy with what we're doing today.
I know I did my worksheet with my calculator.
Okay. All right, but as we go through making corrections, and we're going to work some more problems once we're done going over the worksheet, you'll want that for those. All right, so Genesis real quick. The 2 that you missed while you were out looking for the calculator, 15 inches was the length of the whole side here. If you got 6, that's the length of the bottom segment, and then we just need to tack that on to get the 15. And then for this, we got 3 times the square root of 10 centimeters. Any questions from you on those middle 2 problems on the second page? Good to go on both? All right, let's take a look at the next one. And that next picture where we've got a couple of intersecting chords within the circle. What should be going through our mind here, Chris?
Segment times segment equals segment times segment.
Good. Segment times segment equals segment times segment. Or product of segments has to equal product of segments. We were given a couple of segments here. AP I don't know. BP I know is 4. And then we had a line kind of coming through like this. And I knew that CP was 8 and DP was 5. So really straightforward. When you plug in product of segments equals product of segments, we write out.
Oh, mine was printed weird, so I don't know if I got the right thing. Like mine was kind of
mine too, but I just tried to.
Oh, that's true. The printer does some strange things sometimes. And all right, so you kind of had to fill in the gaps there on the circle. I'm sorry about that.
I did 8 times 5 gave me 40, and then I had 40 divided by 4, which gave me 10.
Yeah, I should have gotten 4x, and then x is equal to 10, and it's inches, which is the correct answer, 10 inches. How many got 10 inches in spite of the weird picture? You kind of figured it out, what it should have been. I apologize for the misprint. Pulling more printers downstairs. All right, any questions on that one? All right, looking at the next picture, one that we've also seen rather recently, and it's the right triangle with the altitude drawn. Now, right here, there's a bunch of different thoughts that could be going through our mind. Just give me one of the things you thought when you saw the picture, Audrey. Good, that's one thing that should go through our mind. Segment is to altitude as altitude is to segment. What's another thought that may go through our mind here, Kendall?
Segment is the leg is to hypotenuse.
Good, segment is the leg is to hypotenuse. Any other thoughts that may be going through our mind?
Segment is legs. What she said, but for the opposite.
Right, they say again, segment is the leg is to hypotenuse. There's another thought that may be going through our mind.
C squared equals A squared.
C squared equals A squared plus B squared, because we've got 1, 2, 3 different opportunities to use the Pythagorean Theorem if that's a route that we choose to go. I gave you that AC was 8 inches, that AD was 4 inches, and the first thing I asked for was BD. There's a couple different directions, like I said, that you could go with this. What did you do to find BD, Audrey?
I used the proportions.
Okay, which proportion specifically? All right, where initially you're not going to solve for BD, you're going to solve for AB, then just subtract away the 4. Or you could call BD x, in which case the hypotenuse would be, well, x plus 4. Which route did you go with this? Do you remember from your, or can you see in your work what you did?
I think I did the first one.
Just do the first. You just called this the hypotenuse x and said, I know I didn't say to solve for AB, but I'm going to do it anyway, because I have a segment and a leg. Segment is leg is to hypotenuse. In which case we would say 4 is to 8 as 8 is to x, and you would have found this hypotenuse to be 16. But that's not BD. BD, class, would be 12 inches, because you just subtract away the 4 from the 16. How many had 12 inches for BD? 12 inches for BD. All right, any questions on that? There's another way you could have gone with that, and you could have instead found CD first. Now, if you did it the way Audrey did and found the 12 inches, you would then probably use segment is to altitude is to segment to find CD. But you could have found CD right away. How? Anyone? Pythagorean Theorem. And by the way, for 8, hypotenuse is double a leg.
Pretty easy other.
There's no true indicator as far as what's given of a 30, 60, 90, but it does happen to be. I would probably use the Pythagorean theorem here, end up getting 4 times the square root of 3 inches. In which case, had you found this first, you could have said segment is to altitude is to, and then found the segment second. So you could have found these out of order if you went Pythagorean theorem, segment is to altitude is segment. Or, like Audrey did, find this using segment is to leg is to hypotenuse, and then use this to go segment is altitude is to segment to find the 4 square root of 3. How many regardless got 4 times the square root of 3 inches for your altitude? Perfect. And then for the last leg, there's now a couple different ways you could go about this. One way would be to go Pythagorean theorem of the whole triangle. Hypotenuse squared equals leg squared plus x squared. Or segment is to leg is to hypotenuse. Either way, should have found BC to be 8 times the square root of 3 inches. How many had that correct answer as well? All right, Jamie, questions? You got the first 2 you said.
Yeah, I forgot to do the last
Just
one.
forgot to do the last one. Okay, all right, questions on this. By the way, notice something. 4, 8, 4 times the square root of 3. That was right here. Observe. 8, 16, 8 times the square root of 3. And observe here, this is kind of a weird one, 4 times the square root of 3, 8 times the square root of 3, 4 times the square root of 3 times the square root of 3, which would be 4 times 3, which would be 12. Remember, we said all 3 triangles have to be similar. Remember? That was the premise, was we had 3 similar triangles. So if one of them is 30, 60, 90, of course, they're all 30, 60, 90s. But anyway, just kind of an interesting point to point out there. That's certainly not always the case with this picture. It happened to be here. Questions? All right, and then the last page was all special triangles, if I remember correctly, and I do. One leg of 45, 45, 90 right triangles, 2 centimeters, find the length of the hypotenuse. Drawing the little picture, like we see over there, could help. Labeling it would help. Didn't necessarily have to, though I certainly did. What was the length of the hypotenuse, Quentin?
2 times square root of 2 centimeters.
Good, 2 times square root of 2 centimeters. What was the length of the other leg, Jamie?
The other one was 2 centimeters.
2 centimeters. How many got both of those correct? Excellent. Next one, the leg across from the 30-degree angle in a 30, 60, 90 right triangle is 5 inches. Find the length of the other leg, Genesis.
10 inches.
Ooh. Kendall.
That's what I got.
Ooh, Chris.
5 times square root of 3.
5 times the square root of 3 inches.
Oh,
Then find the
sorry.
length of the hypotenuse, Audrey. That's 10 inches.
I had it right. I just looked at the wrong.
You looked at the wrong one?
I swapped them.
You swapped them. Yeah, did you draw a picture? Look at your picture really closely, Kendall. Did you label one angle big and one angle small? Did you label the side across from the small X and call it 5 inches? Did you label the side across from the right angle 2x, or did you call the other side 2x?
The other side too.
Gotta memorize the hypotenuse is double. In the 3069, the hypotenuse is double. This is x squared root of 3. And again, this is the biggest. 2 is bigger than 1. 2 is also bigger than the square root of 3, right? Because 1 is the square root of 1. Square root of 3 is square root of 3. 2 is the square root of 4. So that's your biggest. That's pretty big also. That's little bitty. Okay? So you're not going to mess up the x being the short one. It's which of these two? Hypotenuse is that little bit bigger. Questions on those? All right, look at the next one. Hypotenuse of a 30, 60, 90 right triangle is 10 inches. Find the leg across from the 60-degree angle. What did you have for this one, Chris?
Across from the 30, I got
Across from the 60.
Across from the 60, I got 5 times square root of 3.
5 times the square root of 3 inches. Then across from the 30-degree angle, Genesis, 5 inches. And again, Kendall, do you see how it's literally the exact same problem we just worked? This time I put the 10 inches at the hypotenuse square already. How many of both of those correct? All right, and Kendall's learning from it. That's the point of these exercises, to learn from them. So on quiz and test day, we don't struggle. The next one, hypotenuse of a 45, 45, 90 right triangle is 3 inches. Find the length of each leg. Kendall, for some redemption.
3 times the square root of 2 over 2 inches.
Very good, and you did redeem yourself well there. 3 times the square root of 2 all over 2 inches is correct. How many had the same answer? And then for the last one, leg across from the 60 in a 30, 60, 90 is 9 centimeters. Find the length of the hypotenuse, Quentin.
18 times square root of 2 over 2 inches. Or same as.
Audrey?
18.
Oh. The leg across from the 60.
Oh.
Remember, the leg across from the 60 is the x squared of 3, not the x. So if you saw the leg is 9 and you were thinking x, you would have doubled to get 18. But this is the x square root of 3. So what should we have got? Somebody who labeled correctly, Chris?
9 times square root of 2 over 2.
You were picturing a 45, 45, 90 down to 30, 60, 90. Someone else? Redo it. Draw the picture. Start over. Draw the picture. Start over on the last 2 problems. I would start by drawing the labeled picture, then put in the given number. I would start here, then put the number in, not the other way around. You're going to allow the number to influence your labeling if you put the number on first. So don't put the number on until the labeling's done. It's like the facts of the case. Okay, get the facts of the case and then add in some of the extra details. The leg across from the 60 is 9 centimeters. So now to go down to the x class, what do we have to do?
9.
Right, 9 divided by the square root of 3, which, you know we can't leave that, right? We have to multiply top and bottom by square root of 3, and that'll give us in the top
9 times the square root.
Yeah, 9 times the square root of 3. And in the bottom, just a plain old 3, right? Square root of 3, square root of 3, square root of 9, which is 3. And then we can reduce it down. And that's what we should have gotten for the other leg, but that was the last answer, right? The last answer was find the length of the leg across from the 30. That's this answer. But the answer we were initially looking for was the length of the hypotenuse, which would be double, so the answers for the last 2 were 6 times the square root of 3 centimeters and 3 times the square root of 3 centimeters. Questions on those last ones there? Questions at all? Make sure you've got correct answers on here and put it in a safe place you can use to study Thursday night. You want to be able to skim over the problems and make sure you know how to work every one of these, because you're going to see very similar stuff on your test on Friday. All right, once you've set that aside, take your textbooks out. Turn to page 221. Once you got those set aside in a place where you will not lose it, nor forget where thou hast placed it, turn to page 221. And let's look at some more numerical exercises. Not too different from what we were just working on. Page 221, and look at exercise number 2. Page 221, look at exercise number 2. Ethan, what are we trying to determine in number 2?
Is DE parallel to AB?
Yeah, is DE parallel to AB? In class, if DE were parallel to AB, what 3 proportions must be true? Say them with me. Bottom is to top as bottom is to top. Whole is to top as whole is to top. Whole is to bottom as whole is to bottom. So how do I determine if DE is parallel to AB, Ethan?
Go through all this again.
Now, how do I determine if it's parallel?
If they were
thinking ahead. If
He's at a loss for words here.
I can't.
He's like the kid who gets in front of the class to do the oral book report and his mind goes blank. Quentin, help your classmate out here.
If you cross multiply, it should be equal.
So in other words, if one of those proportions is true, right? If it were parallel, then one of those proportions would have to be true to get that, right? So find out, is one of those proportions true at your seats? Solve number 2. Verdicts are coming in. The jury is deliberating. How many say yes, the line is parallel? How many say no, the line is not parallel? Well, the problem is we have incomplete information, right? We need to get a little bit more information, so we're going to call on witnesses, and we're going to find that this top segment should be 4. We're going to find this bottom segment would have to be 9. See, that allows you to either say whole is to top as whole is to top, or it allows you to say whole is to bottom as whole is to bottom, or it allows you to say bottom is to top as bottom is to top. And you can check any one of those to see if it's true or not. They're either all going to be true or they're all going to be false. In this case, class, they are all true. So is the line parallel?
Yes.
Yes, it is. So the yeses were correct in their verdict. Questions on number 2. Let's take a look now. Drop down to number 6. Go ahead and read this for us, if you would, Chris.
AB, a diameter of a circle, equals 12 inches, and AC is a chord such that angle BAC equals 30 degrees. Find the length of AC.
All right. First thing we should probably do, class? Draw a picture. Good. I like that Ethan's answer was so quick. Draw a picture. That should be the first thing we do. Because again, although we're not actually doing a proof, mentally we are thinking through some similar thoughts. How do we draw the picture? Well, draw a diameter. Call it AB. Might label that it's 12 inches. And we've got a chord AC. So we know that has to start at A, go to C, but it's drawn in such a way it says that angle BAC is 30 degrees. Let me say that one more time. 30 degrees. Your brain should suddenly be thinking something. 30, 60, 90. Only problem is I don't even have a triangle.
Just draw BC.
But if I were to draw BC, would it be a 30, 60, 90?
Yes.
How do you know?
Because it's an x-craft angle and a semicircle.
Diameter means semicircle. Semicircle gives us the right angle. Yes, it is a 30, 60, 90, where the hypotenuse, AB, the diameter, is 12 inches. How do I represent the hypotenuse? 2x. How do I represent chord AC? X times the square root of 3. It's across from your 60. How do I represent chord BC? What did it want us to solve for? AC. But in order to get AC, we first have to find BC, which is 6 inches, which gives us 6 times the square root of 3 inches. Do we see how to think through problems like these? All right, again, when you know there's a 30 or a 60 or a 45, by all means, use special triangles. Here you really had to anyway. If you don't know for sure, though, try to default to Pythagorean Theorem or something. Let's go to number 8. And this sounds a lot like a problem from the handout, but it's a little twist different. Find one side of a square if a diagonal is 24 inches. What should we do? Draw a picture. And they give you the length of the diagonal. And they ask you to find the length of one side of the square. Solving at your seats. What do we know about the sides of the square, class? They're all equal. What do we know about the angles of a square? They're all right angles. In particular, that. is a right angle, which means this is a right triangle. But if it's got equal sides, it's an isosceles right triangle, or we often call it a 45, 45, 90. We don't think it is. We don't think it kind of looks like one. We know it is. How do I represent the sides? How do I represent the hypotenuse? So to find x, all we have to do? Divide away the square root of 2. It's a rhyme. So what do we get for the side, anyone? 12 times the square root of 2. Inches. Questions on this one? Do you see how to spot the 45, 45, 90 there? Questions on that? Let's take a look at number 10 now. This one sounds really familiar. Diagonals of a rhombus are 12 inches, 16 inches. Find one side. At your seats. Hopefully you remember what we did on the homework handout. (30, 60, 90 class? No. Pythagorean Theorem?
Yes.
Yes. And what do we get? 10 inches. What's the perimeter?
24 inches.
40 inches. If one side's 10, you know they're all 10, and there's 4 of them, so 40 inches would be the perimeter. Number 12. Similar to one problem that I asked on the homework handout, but a little twist different. But we still have what major shape in 12 class? Equilateral triangle. In the equilateral triangle, we draw an altitude. What should we be picturing here, class? 30, 60, 90. Do we know there's a 60? Yes. In an equilateral triangle, we do know there's a 60. And we know the altitude is 9 inches. Find one side. How do we represent the side? Good. 2x. How do we represent the altitude? And how do we represent half the base? Take a moment. What do we have to do to get the x first, class? Divide away the square root of 3 to get 3 square root of 3. So, what's the length of one side? 6 times the square root of 3 inches. How many have this answer correctly? By the way, what's the perimeter? 18 times the square root of 3 inches, because there are 3 sides, each of which is 6 times the square root of 3. Questions on this? Got several of these to work for homework this evening. Page 221, to number 7 through 13, the odd. Page 221, 7 through 13, the odd.